Nix is many things. It is a programming language, it is a package manager, it is an operating system if you so choose, and it can also be a very powerful build system. In this video, we're going to go through how you can build C++ programs without needing to use cmake, but instead using a rather more beautiful language, in my opinion, Nix, using tools provided by the Nozzle package. My original plan for this video was to try out using Copilot for a multi-language project. I use Nix to tie together multiple language projects, and so I figured that would be the best approach. However, although Nix popularity is definitely on the rise, there's still not a lot of awareness about how it works and how to use it. So I figured I would start off with a project that uses Nix and just build C++ projects for now. And I can get any feedback from this video and then tie it in to a later video where I go crazy and use C++, Node.js, Haskell, Python, and as many technologies as I can throw together to build a website. This is an example of a Nix flake. You have a set of inputs and a map from those inputs to final outputs. The outputs that are provided are for a range of different systems, x86, 64, ARM, Darwin, and so on. And so flake-utils is a handy library that allows you to express how things are built per system in a functional manner. Nix packages is just the largest, I believe, package repository of any kind in the world. So the outputs that you're providing are shells and packages. So shells are for when you're developing this and or working with it directly, and packages are the outcomes. So if someone were to pull in this flake and want to run it, it would explain what is to be run or what is to be brought in as a dependency, for instance, libraries. So I can, in my current shell, I can try and run Clang, and it's going to tell me, hey, you don't have Clang. All I need to do is say packages.clang. Let's make that Clang 15. And I can now run Clang. And it's going to say error, no input files. This environment management is very much done by Nix, but also with the help of direnv. That's D-I-R-E-N-V. With the help of this envarc file, it's saying that when I am inside this directory in a terminal, I want to use the dependencies provided by the flake. So if I come out of this directory and I run Clang, it's not going to work. But in this directory, it is going to work. This is a very nice development approach because it means that my dependencies are specified in whole by the flake. If I were to send this flake file to you and you were to run it, it would automatically ensure that you have Clang 15 in. What this basically means is that it's hermetic. I have specified in entirety all of the inputs required to produce the outputs. There's no dependencies on my system. Anything I've got installed is irrelevant according to Nix. It is all to do with what is specified exactly here. And just to give an example, I can get rid of Clang now and reload my direnv, and then I can try and run Clang, and it's going to error out. So that's just a quick way of explaining how these shells work. You specify everything you want to be able to use, and it provides it for you. The packages are outcomes such as libraries or binaries. And so Copilot has got this wrong. I don't want to produce a shell as my default package, but I might want to say packages.hello. This is GNU hello. And if I say Nix run, hello world, you'll notice that it's warning me my Git tree is dirty. This is just because I have uncommitted changes. Nix flakes are fairly sensitive to Git, so if you have files in your local file system that aren't added to Git, Nix flakes won't be able to see them. This is quite handy because it prevents you from making big mistakes, such as committing and pushing and getting a different result if you're using your remote version than your local one. So it's a kind of a safety feature. It's also a bit of a pain, but you get used to it. So in this instance, we have run packages.hello. This is the default. I can also run this through ./default. Boom. Same thing. So I can also name other packages such as cowsay. and I can nix run cowsay. Now it's just going to hang there because cowsay obviously takes input. In order to provide that input, you do a double dash, and then you can provide your input or any flags that you might want to run. But in this case, just the input, and I'm going to go howdy. There we go. Now let's go on with building something. I'm going to be using C++. Now Nix works very well with cmake, but I'm not going to be using cmake. I don't like cmake too much. So I'm actually going to be using Nozzle. Nozzle is a project of mine which allows you to build C++ using just the Nix language. Now, the reason it's called Nozzle is because it's inspired by Bazel in just the function names and things like that, but it is written in Nix. So Nix, Bazel. I didn't want to call it Nasal, so I called it Nozzle. In order to bring Nozzle in, I'm going to have to add it to my inputs. So I'm going to call it Nozzle base because I'm going to instantiate it, and I'm going to call the instantiation Nozzle. It's just the approach I use. So I'm going to bring it in from GitHub, like so, and I'm not going to tie a revision to it because it doesn't matter for this case. So add it to my function, and then I'm going to add it to packages as an overlay. I'm not going to explain overlays or fixed point combinators because that's a minefield, but just take this for granted for the time being. So I'm going to add it as nozzle base .lib. So lib is something that's exported by nozzle base, and I'm going to provide my packages to it, and then any time that it's going to use, for instance, C++, like GCC, or anything like this, it's going to take it from the packages I'm providing. So I'm going to inherit packages. This is equivalent to saying packages equals packages. It's just a shorthand. And then I'm going to do that. Boom. We now have packages.nozzle refers to a nozzle project that is instantiated here. So next I'm going to say that I want to have an example program. I'm going to call it examples, in fact a set of examples. Examples is packages.nozzle .add subdirectory. I'm going to call it path equals examples. And then I'm going to provide a number of examples from this directory, a number of applications, binary outputs. So let's first make some and then add it to our packages. In order to do this, I'm going to add a directory called examples. I need to git add by adding it to Git, that just tells the flake where it is, that it exists. So inside of this, I'm going to add a build.nix. This is kind of like similar to how you would create a build.bazel in Bazel. Build.nix, and inside of this, notice that build.nix is up red because I haven't committed it. But anyway, this is going to take in packages and nozzle, and it's going to provide an overlay. So it's going to take in self super. I'll explain this in a second. And first of all, I'm just going to create a example one, and it's going to be a nozzle.cpp binary. Source is going to be, example1.cpp. Nice and simple. And it's not going to have any dependencies. I'm not going to have any libraries that I'm bringing in or include or header only or anything like this. What I'm going to do is add my build.nix and there's the example1.cpp later, but for the time being, let's create example1. Cool. And I'm going to just say include C standard IO. And there we go. It knows what I'm going to do. Simple as that. So my CPP binary is going to use that as a source. It's going to build it, and it's going to produce it as an application that we call example1. Then in my flake.nix, I guess I'm going to call this example1 too. Is examples dot example1. Excuse all the typos. I've got a keyboard that is not really that helpful if I add this angle. So all I need to do here is now say, just reload my flake, and then say nix run example1. And it's saying that examples doesn't exist because I need to git add. Okay, so now it's complaining that I haven't given it a name. So I now need to give it a name. So name is, I think the name doesn't matter too much, but everything needs a name. So nix run example1. There we go. It's now saying hello world. And just to prove that this isn't just the GNU hello and I made a massive mistake, I'm going to say hi, I'm Jake. There we go. So this is obviously a ridiculously trivial program. So let's add another one called example2. And this one, I'm going to, it's also going to be binary, but I'm going to give it some dependencies. Well, Copilot was very handy there. I'm going to actually not use example1 as a dependency because it doesn't make sense. But what I'm going to do is say, I don't know, I'm going to bring in packages.format9, and I'm going to then say and add it, include format.h, int main. Copilot is awesome. So that, however, I do want a new line here. So I'm going to run example2. Now you're going to tell me what I've done wrong. Git add. Okay, next run example2. It's saying I didn't provide it because I forgot to add it here. Now I'm going to cheat a little bit, and I'm going to do this. This is basically a way of saying everything inside of examples, add it to packages with the name it's given, the name that's provided. So, so I do this, run example2, and it's saying hello world, I am Jake again. And just to prove this is not example1 running, let's add an exclamation mark at the end. There we go. Hello world, I am Jake. It's pulling in format, done. This is kind of like the easiest approach I can imagine. Now, format 9 comes from Nix packages. I can also add format 8. I could add sputlog, and so on. So let's think about what happens when we want to create our own library. So I'm going to say we're going to make an amazing library. Let's call it printer. CPP library. I'm going to, there we go. I'm going to call it, give it h.hpp, God. And then source printer, no, let's make it header only. Let's make it header only to begin with. And so example 3, nozzle.cpp binary. I mean, it doesn't really matter. Now I'm surprised, there we go. Can it get it? Can it get it? No. Okay. Perfect. And then I'm going to first need to create example3.cpp and printer.h, but that's all fine. And so let's say touch examples example3.cpp and printer.h. And format.h, why not? And then void tell the world string view message. I mean, it gets it. Perfect. So obviously it's a header, so I'm going to use pragma once. I do not like using pragma once, but hey, it's quick and simple. I prefer include guards. They're standard C++. Unlike Pragma once. So I've got this, and so I've got my printer.h, and so I'm now going to have to add that as my dependencies. Packages.format9. And okay, so let's go to printer.h, and I'm going to say from my header only library. And then example 3, I'm going to include examples printer.h, and I could just use printer.h, I could use example/printer.h, like the entire directory structure is bubbled up. It just knows this is what I'm going to do. Like, it's different. Like, okay, so let's try this. Okay, so it's saying that printer is missing. This is because I need the previous iteration to have defined printer such that, yeah, I'm not going to go into overlays. Okay, so it's saying that, so I need to, there we go, for my header only library. So this is quite trivial. Let's make a another printer. So let's grab these. Okay, let's really try Copilot here. I mean, that's kind of cool. So example 4, and let's just see. There we go. So that's awesome. And so this has now got a header, and it's also got it's got. I don't want it using printer, so I'm just going to call it printer2. Really imaginative wording here. So. So, and also I'm going to touch examples. Cool. So that should already be up to date. So I've got my printer2.h, and it's going to have the same signature. And I'm not going to include that. I'm just going to void tell the world. The source can worry about the dependency. And so then printer2. I'm going to say include printer2.h. I like doing things from the project root. And then I'm going to, it's not in main, I'm going to call it so what we're going to do is include format.h, and then from my compiled library, there we go. Thank you very much. And then so I've got my printer2.h, which is saying, tell the world, and this provides the implementation. Do I have my program once? Yes, I do. So then I could just copy this, and this is going to use printer2.h. Perfect. So I should now be able to run example 4. Cool. This is because it's printer2 should take sources, not source. Binaries, I've just got one source. Yeah. Libraries, I've got multiple. And so it's done this. And it's telling me I need string view, which is kind of obvious. So include string view. There we go. From my compiled library, hello world, I'm Jake. Now, what if I want to, in my example 4, just use printer.h. It's not going to be able to find it. The reason is it's not providing the entire directory, it's just providing the dependency it's been given. So if I tell example 4, hey, you're now using printer.h, which is not specified as a dependency, it can't see it at all. This is by design. It is all about specifying your dependencies. If you wanted to make a larger library that combines these two, you can, which will be helpful if you're going to be, using these in common a lot of the time. But do be aware that if you then go and change the printer.h file, that's going to trigger a rebuild of everything that depends on it, even if it doesn't include it. So in those situations, you'll want to break down your dependencies, keep them nice and separate. So let's take this one step further. We have defined within this subdirectory, we have defined printer2 as a library. Now, what if we wanted to use it elsewhere? Well, let's create a new directory called other examples. As you can tell, my naming conventions in this video are strong. So let's add a build.nix, and let's also add example 5. And I'm going to just write the example 5 first and then the build. So include examples printer2.h int main. There we go. From other examples. So that's everything we're going to need for that file. Then what does my build.nix look like? Well, I'm going to need to import or grab packages and Nozzle. We're also going to need something else in a minute. I'm going to create our overlay, and inside of this I'm going to define example 5. Now inside of this I'm going to call it name example 5. I've noticed that when there's a hyphen, this doesn't work so well. It can't find the resulting binary. The name I said before doesn't matter. What it's actually doing is it's creating a directory in your Nix store, and inside of that there's a /bin, and then inside of that there's a binary, and this name corresponds to the name of that binary file. For some reason when there's a hyphen in there, Nix can't find it. I'm going to work on that. So our source is example5.cpp, and our dependencies, and we're going to need to name our dependencies from examples. Now, how do we do that? Well, let's just call it p2 for the time being, printer2, and we're going to pull this in our inputs. How do we pass this from the outputs of examples? Well, we do this through the flake file. We can now say other examples is packages.nozzle.add subdirectory, just like before. I'm going to, it's already, I like Copilot for things like this. So then I can add that as my dependencies. And this is a map, so I'm going to call it p2 equals examples dot printer2. And then I've added other examples there, so much for continuity. And so anything defined inside of other examples will now be present in packages. So in this, we've got our build.nix. We have our p2, which is the same name as as what's passed in from the flake. So p2 is examples.printer2, and then inside of this, we're pulling that in and just adding it directly as a dependency. So what happens if we are to run this? Well, as you know, I need to git add this. Okay, and now from my compiled library, hello world, I am Jake from other examples. So it's quite simple to just, once you have exported this library within this attribute set of your build.nix, you're able to access it from within the flake and then pull that out and give it somewhere else. And so this is kind of like your control center. So I mentioned earlier that Nix packages is the largest repository of software anywhere, but one thing it doesn't have. I mentioned earlier that Nix packages is the largest software repository that I'm aware of, but it doesn't have everything. And one example of something it doesn't have is Crow. Crow is a web server written in C++. It's kind of like very similar to Fast API in Python, but it's in C++. That's not present in Nix packages, and we can add it quite easily. This is how we do it. In our overlays, I want to access this through packages, so packages.crow, and in order to do that, I'm going to need to inject it into packages. So I put it in my overlays, and I'm going to add it within this same overlay because there's no reason why I can't. So I'm going to call it crow itself.nozzle package wrapper. I'm going to give it a name. I'm going to give it a derivation. And what I'm going to do is provide a file, crow.nix. And then I'm also going to provide some C flags. Okay, so now we're good. So I need to define my crow.nix first, but just know that from examples and other examples, I'm able to now say packages.crow and it will correspond to this derivation. So package wrapper is a functionality within Nozzle that takes any derivation, and if there are libraries that are output from it, it grabs those. If there are headers output from it, it grabs those and it exposes them to whatever needs them. It decides what needs to be added to include headers. It decides what needs to be added to linking commands and so on. So Nix packages.format is actually exposed as a cmake dependency. And I didn't want to deal with all of that. So what I did instead is just extract out the headers, extract out the shared libraries. The headers are in their own separate derivation and they are provided to the GCC when building the example CPP files. And then those are linked against the shared libraries later. So it's all just using this package wrapper functionality. Now with Crow, that can also be a cmake dependency, but I don't want to do it like that. Just to give an example, I'm going to go pure Nix and just use stud make derivation. So let's get on with that. I'm going to add crow.nix. Now best practice would probably be have a third-party directory called third parties and then put that in there, but this is only a small project for now, so let's get on with it. Now I'm not going to write the derivation out by hand. For instance, there's a large hash in there that I would have to write out, so I'm not going to waste your time. Instead, I'm just going to copy it from another project I've been working on. And so what I'm doing here is I'm using the standard environment to make a derivation. I'm giving it the package name crow. Now, the reason I'm calling this version custom is that I'm not using a tagged version of Crow. I'm using a more recent commit. The requirements for using Crow will include boost ASIO, and zlib. The source it's coming from is github.com/crowcpp/crow. I'm using this revision, and once it's downloaded, it should have this SHA-256 sum. So once that's downloaded, I need to unpack it. Now, as Crow is a header-only library, I'm only interested in the include directory, so I'm going to extract that out, and then I'm going to copy that into the final destination, which is $out. The result of this will be a directory in my Nix store, which includes this include directory. And then anytime I pass this as a dependency to any Nozzle project, it's going to pick up, hey, this has an include directory. I'm going to add it to the include path, and we're good. So let's build something. I will stay in my other examples, and I'm going to add a new example. Knows what it's doing. And instead of P2, I'm going to use packages.crow. So let's build ourselves a web server. You gotta like that. Okay, so this is going to serve on port 18080, and it's going to be multi-threaded, and the root is just going to report back with hello world. So let's give this a go. Obviously, helps everyone in the terminal. Now this is going to take a bit longer to build because Crow takes a while to build, but that's okay. And it's running. Now, let's add another terminal. Now, let's make a request. We're on port 18080. Hello world. How nice is that? So let's add some more functionality. Now, how can we do that? Well, first of all, we can include format. Notice that I will need to add this to my dependencies. So now we're going to make a new root. Okay, that's not quite what I need, but that's okay. I'm going to say that'll do. And default response is HTTP OK. So I think we're good. Now we're going to need to go into, oh well, let's try running that. Okay, it's going to complain we don't have format. This is because, as I said, we need to add it to our dependencies. It's now running. So again, we get hello world, but if we want to go echo, it's responding back with howdy. If I don't have message, I need a message. There we go. Well, that just about covers it for now. I hope you enjoyed the video, and I'll see you next time.